Hi everyone, today we're going to talk about how you can use the Pythagorean theorem to find missing side lengths of a triangle. As a reminder, you do not need to write down everything that we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember, you can pause to jot down important notes, rewind to view information again, and fast forward if you think you got it. But don't fast forward too much that you'll miss out on something important. Alright, so as a review, the Pythagorean theorem is a squared plus b squared equals c squared. Remember that a and b are just names for what we call the legs. Those are the shorter sides of your right triangle. And c is for the hypotenuse. That's the longest side of your triangle, and it is always going to be opposite to the right angle. So it's always going to be right across from the right angle, the square right here. So even if you can't tell which one is the longest side, it's always going to be the one across from the right angle. And that's because the right angle is actually the biggest angle in your triangle, so it's going to force the opposite side to be the longest side. So it doesn't matter which one you call A or B, they're always going to be your shorter ones. Doesn't really matter which is which. But the C is the most important. It's the longest and across from the right angle. The Pythagorean theorem only works for right triangles. If there isn't a right angle on your triangle, it's not going to work with the Pythagorean theorem. When you get to geometry and trigonometry, you'll learn how to figure out missing sides and angles for all types of triangles, but for now, only right triangles. If you don't have this in your notebook yet, make sure that it's in it now. Okay, and now we're going to watch two videos that's going to show the Pythagorean theorem. One is with paper, so what they're going to do is they're going to show a squared plus b squared equals c squared using these square units. So if the A side were 3 square units long, it will be 3 by 3 square. If the B side were 4 units long on one side, it'll be a 4 by 4 square. And the C, if it were 5 units long, it'll be a 5 by 5 to show the squared. 5 times 5 squared. And then the second one will use water to show that a squared plus b squared equals c squared. Alright, that's all we're going to watch for that. So you'll see that the a squared plus the b squared actually ends up adding up to the area of the c squared. And we can fill the a side with water and the b side with water as well and see if it fills up the c side, the c squared. And it does. So that's a squared plus b squared. A squared plus b squared equals c squared. Let's do some problems now. So in these problems, they're going to ask you to solve for the value of x in the triangle shown below. Let's do this one together. The first thing I'm going to do when I have these problems is to first find my c, my hypotenuse. Again, it's going to be directly across from my right angle. So this one is c. Again, it doesn't matter what you label as a and b. I could have switched these up and it would have been totally fine. Then I'm going to write down the formula, a squared plus b squared equals c squared. And I'm going to substitute in 7 for a and x for b. Substitute 9 for c. And then don't forget we have our squares. Squaring, remember, is multiplying by itself. So this is 7 times 7 plus x squared equals 9 times 9. 7 times 7 is 49. 9 times 9 is 81. Biggest mistakes that people make is making this into 7 times 2. It's not 7 times 2. It's not 14. And this is not 18. It's 9 times 9, 81. Now you're going to solve it normally like an equation. You're going to subtract 49 on both sides here. And then you have x squared equals 81 minus 49. So I'm going to do that in my calculator, and I get 32. Now you need to get x by itself. If you remember from previous lessons, the opposite of squaring something is square rooting something, because these two cancel each other out. It's like you impaled it. And then you need to square root both sides. So this answer is the square root of 32. And that is an actual answer that we have. Okay? If you were to check this answer, we would just put everything back. So it would become a squared plus b squared equals c squared. A squared was 7 squared. B we found was square root of 32. That was the answer for B. We still got to square it according to the formula. Equals, and our C was 9 squared. So this will become 7 times 7 plus square root of 32 times square root of 32 equals 9 times 9. 7 times 7 is 49. Square root of 32 times square root of 32 would just become 32 because the square root, if it's multiplied by itself, will get to that actual number. We wanted to find a number that would multiply by itself to get to 32. So now it's being multiplied by itself, so it's going to get to 32 equals 81. 49 plus 32 should equal to the 9 times 9, which was 81. Okay, so this answer may look weird, but it's because later on when you square it, it'll get you back to 32. And the only reason why we needed to keep it at square root of 32 is so that it can work in that formula later on. If a problem asks you to find the answer and round to the nearest tenth, all you would do is just put into your calculator the square root of 32, and the actual square root of 32 is 5.65685, so on. We know that's an irrational number because it's a square root and it goes on forever with no pattern. So if somebody wanted the answer as rounded to the nearest tenth, then you would just round this one to a 5.7 as the nearest tenth. But this problem doesn't have it like that, so you would just keep it as square root of 32. If it doesn't tell you to round it, then you want to keep it as a square root because that's going to be the most accurate. All right, and then here is another problem where they're going to ask you to find the value of x. Go ahead and pause the video and try this one on your own. So what you should have done was set up your equation, a squared plus b squared equals c squared, label. The one across from the right angle is always your c, doesn't matter what the other two are. We're going to replace a with 7 in our equation, b with 9, and c doesn't have anything, so we're going to keep that as x. You could also keep it as c if you want. That way, you know what you're solving for. This is 7 times 7 plus 9 times 9 equals x squared. In this problem, the missing side is the hypotenuse. So notice how you have the a and b, and you're going to solve for your hypotenuse. So this is 49 plus 81, same numbers actually, equals x squared. Your answer is not going to be square root of 32. Okay, because these two smaller numbers need to add up to the bigger number. 49 plus 81 need to be added together. Notice how that's different than the previous one when a leg was missing. We had to do a subtraction for that one. Now there's no subtraction because we have both the legs. They just get squared and added to each other. Equals x squared. Remember the opposite of squaring something is square rooting it. So then your answer is the square root of 130. If I put in the square root of 130 into my calculator, it's not going to be a pretty answer, so that's why they probably want to keep it as a square root, because it's not a perfect square. Okay? So those problems will ask you to find the value of a missing side. The last type of problem that you could be asked is if they give you all 3 sides, and they want to know which side lengths, A, B, or C, actually form a right triangle. So these are all side lengths, 3 sides of a triangle. They want to know which one of these 3 is actually a right triangle. So that means it has to follow a squared plus b squared equals c squared, the Pythagorean theorem. So what I would do is I would just try out A. 3 squared plus 4 squared has to equal 5 squared. And why did I put 5 as my hypotenuse? Why couldn't I have written 3 squared plus 5 squared equals 4 squared? That's because the hypotenuse, if you remember, the c, is the longest side. So your biggest number has to be at the end. Okay, so if I set it up any other way, it would be wrong. It wouldn't work. For b, I'm going to set up 7 squared plus 8 squared equals 9 squared. 9 is our biggest side, so it has to go at the end. And then for c, I'm going to set up that as well. I could really quickly put into my calculator the square root of 95 to just double check and see that it's the biggest. Yep, it's about 9.7. And then remember, you can switch up a and b. I don't have to put 3 squared plus 9 squared. I could put 9 squared plus 3 squared equals square root of 95 squared. Okay, these two can be mixed up, but the hypotenuse has to be the longest side. Go ahead and pause the video and try them on your own. See which one works. All right, so let me get a different color. 3 times 3 is 9, plus 4 times 4 is 16. That should equal to 5 times 5. 5 times 5 is 25. 9 plus 16 is 25. Okay, that one works. It says choose all the answers that apply though, so some other one might work as well. This is 7 times 7, this is 8 times 8, and this is 9 times 9. I want to write it out in case I do something silly on a quiz and I just think it's 7 times 2, 8 times 2, 9 times 2. This is 49 plus 64 equals 81. 49 plus 64, oh, I can already tell that's not going to work because this is a 3 at the end. And then the last one, 9 times 9, 3 times 3, and this one is going to equal to 95 because it's the square root of 95. So if it multiplies by itself, it's going to go back to 95. That one's easy. This is 81 plus 9 equals 95. Does 81 plus 9 equal to 95? No, it equals to 90. So the only one that worked was 3, 4, and 5. And 3, 4, and 5, if you notice, was the one in the video right here. When they set up the triangle, there was one side that was measured 3 units long, 3, so it becomes 3 squared, 3 times 3, 9, times by 4, 1, 2, 3, 4 units, 4 by 4, which is 16, and then the hypotenuse was 1, 2, 3, 4, 5 units long, so it became a 5 by 5, 25. This is a 3, 4, 5 right triangle. It's the most popular right triangle because it's easy to remember, 3, 4, 5, and it's always going to work. There are about like 4 different popular right triangles that people memorize. So now, fair warning, if you ever see a 3, 4, 5, you don't have to test it. It's going to be a right triangle. It's the most popular one. Okay, so let me know if you have any questions as you work on these problems, and I'll see you in class.